Hi, this is Julian. This is going to be a very brief code walkthrough for the NES example program that I made. I figured I would start by showing what the program can do. So it starts out by loading up this Mario sprite on an empty white background, and using the directional pad you can move Mario around in any of the 8 cardinal directions. Additionally, if you press the A button, Mario will jump. So that's really all it can do. And I will say that this started out with example code I found online. All the example code would do was move the top left half of Mario's head left and right if you pressed A and B. So obviously I added a lot of functionality. I changed the colors around a lot. I added the movement of all 4 of the sprites simultaneously, and I let them move in any direction rather than just one direction, and the jump code is all completely custom made by me. So I did start with example code, but I had to understand it very thoroughly before I could add anything to it, and I ended up changing basically every line of it. But so, without further ado, let's go diving into the code. So this is a 6502 ASM file. This file will get passed to an assembler, and the assembler will generate a ROM file that'll get run by an emulator. If it were trying to get run by an actual console, it would, instead of outputting a ROM file, output data that would get written onto the cartridge. But that's kind of besides the point. So I really just want to look at the sort of overall structure of this ASM code, because I figure if you want to look more in depth into it and learn more about exactly what's going on and feel more certain that I know exactly what's going on, I have a much longer video that basically goes line by line explaining absolutely everything that happens and absolutely everything that I know that happens, as well as this other ASM file with a lot of comments explaining, again, line by line exactly what's happening. Every single line. This will serve as a sort of starting point for you, hopefully, for grading this. So basically, the way the NES gets its first code starting point is by the reset label. So there's a vector in the NES that tells where it should look for code to run resetting. This is all defined down here. So we tell it that we want to go to the reset label when power on happens or when the reset button is pushed, and we want to go to the NMI code label when we get a vertical blank and it's safe to update sprites. So what's going to happen is power on happens, and then we go to this reset label right here, and the code starts running. But before all that, I want to show at the very top of the file we have a header. All the header does is it tells the assembler how big the program is right here. It sets up a couple variables here and a couple of constants here. So not a lot going on in the header. But in terms of the actual code, what reset does is you can see we have a lot of labels here. The labels aren't doing anything besides serving as creating memory addresses that we can refer to later. These aren't actual functions. There's no returning, there's no stack manipulation, nothing like that, because this program is so simple. So basically what happens is the power gets turned on and this reset label gets run. And so this first block disables everything that has to do with other interrupts. There's a third kind of interrupt that I'm not going to get into called IRQ. I never actually understood how it works, and it's not used in this tutorial. But basically, the first step is disable all the other interrupts, so that as we're loading our game and getting everything set up, we don't get interrupted and ruin our loading. Then we wait until the PPU is up and running in v-blank wait 1, and once the pixel processing unit, the graphics, is ready to go, we clear the memory out with this fairly complicated looking but actually very straightforward loop. all this clear mem loop does is it sets the memory addresses 0000 through 07FF, in other words, through 0800. It blanks them out, and that's because those 800 addresses are internal memory, so that'll be stuff for like variables and whatnot, and we want to clear that out when we reset to make sure that there's no junk RAM when you turn on. And then I have some variables get initialized for my jumping code, whether Mario's jumping at his current velocity, both start at 0 and get set later, and then we wait for the PPU to be ready once again, and this is all like as it's powering on the initial loading. Then all this giant block of code right here is just serving to load the graphics. So we have these palettes defined somewhere on the cartridge, and we need to get them onto the PPU's video RAM. And so that's what this loading does. We load the palettes into the actual PPU off of the CPU's memory, which is on the cartridge. So again, that's important to note that when I'm talking about CPU memory, I really mean both the cartridge memory and the internal RAM of the CPU. So we need to get it off of the cartridge and onto the PPU. And that's what load palettes does, and that's what load sprites does, is gets all of our graphics data ready. So this is loading Mario and loading the color palette so that Mario gets the right colors. And then we enable sprites, we enable NMI, and basically say, okay, we're ready for the program to begin. We've got our graphics all loaded up, we've got our variables set to their initial condition, we've cleared memory. Everything is ready for the reset, and now we can enable NMI so that next time that we get a vertical blank, the game actually starts. And so now reset finishes by jumping to forever and just infinitely waiting for NMI to get called, because the NES works by interrupts. So first the reset interrupt happens, and then NMI gets called for later when the code needs to be updated. So then the rest of the code is all inside of this NMI label, and again, we don't have any returns until the very, very bottom. And all of this is doing all of my game engine code and all of the sprite updating and reading the controller and everything. And so that's actually not ideal. What NMI should do is just update all of the sprites to where their current position is, and then return and start working on the game engine separately. But my game is simple enough that I can just do everything inside of NMI, and it's all fast enough to run within the time of one vertical blank. So anyways, what this does is first, it does a special, this is a confusing little bit of code, but when you load an address into 2003 and 4014, the PPU knows that that's the address you want to start pulling sprites directly, so it does a direct memory access, and it just pulls 64 sprites starting at, in this case, 0200. That's basically a hack that they put into the NES to avoid having to make this same loop happen for every single game. But I won't get into that, because that's what this video is for. So then it enables the controllers by latching to them, and then the rest of this is all reading controller data. So we read A to check if the A button is being pressed, and if it is being pressed, then we need to start making Mario jump. And so if he's already jumping, we don't do anything because we don't want double jumping in this game. And if he isn't jumping already and we pressed A, then we set his initial jump velocity. We set his Y velocity to be the jump velocity, and then every subsequent frame is going to subtract from his velocity while also moving his position up. So that's how you simulate a jump. That's how I'm doing a jump, is basically adding velocity to his Y position and then subtracting from his velocity every frame, which gives a nice parabolic motion, as you saw before. And then the rest of this controller stuff, B, select, and start, are all ignored. up, down, left, right all do the same thing, where if they are being pressed, they change the sprite's position appropriately, either the X position or the Y position, and either adding or subtracting depending on if it's up, down, left, or right. And that's it, basically. So the real sort of entire overview is the code gets injected to by checking reset, and it does all its initial loading, and then every single frame NMI gets called, and that's where we update the sprite's position and where we update the game engine internally. There is a little bit of boilerplate stuff here. This is where we define the palette. This is where we define the sprites. I won't get into any of the details there. And this is where we pull the graphics data from a binary file called mario.chr. Again, won't get into any of the details, but the overall structure is you call reset, you call NMI based on interrupts, and in NMI is when we do all the controller handling and where basically the game happens. So NMI is essentially every frame of the game, how it should be updated, and in my case that has to do with jumping and whatnot. So that's pretty much it. That's the game. I learned a whole lot. I really do feel like I understand on a quite deep level how the NES works. I feel like given a summer I could go out and make an NES game. Don't know if it would have sound or not, but yeah, this is an extremely, extremely worthwhile project for me. I really learned a lot, and I had a lot of fun doing this. I procrastinated on pretty much all my other work to learn about the NES and to work on this code. Despite the simplicity of this program, it took a lot of background knowledge, and so the actual code and getting the jumping to work and stuff like that was not the majority of the problem. Majority of the issue was demystifying the example code and getting to learn how absolutely everything works. So that's it for this video. If you want more details, the ASM file, I'm turning in one with comments and one without comments. So you can check out the one with comments. They're very detailed and they explain every single line, what's going on, and I'm also going to turn in a longer video, which I don't really expect you to watch because it's going to be like 45 minutes long, somewhere thereabouts. And so if that's just too much for you and you don't want to bother with it, that's fine. But if you do want really a lot of detail, you can listen to me ramble about the code in that longer video. So that's pretty much it. That's my project. I had a lot of fun doing it, and the class on the whole was really a lot of fun, really interesting stuff. So yeah, thanks for watching.